Today we are going to talk about the relationship between two variables. The only thing we are going to consider in this unit are comparing two variables, not one variable. Now, there are so many cases that we can find the relationship between the two variables using graphs. And that's what we are going to consider in this section. Now, as you know that graph is a visual representation of the relationship between two quantities, or as you know, two variables. For instance, your age and your height, your age and your income, and so forth. Now, what these graphs they show is how one of the variable is dependent on the other one, meaning how one variable changes as the other one changes. So let's consider a couple of examples here. The first thing is we have to describe the relationship as shown in this graph. As you can see, the relationship between hours worked and the earning is linear because it's shown as a line. This means as hours worked, your earning increases. The second example shows the relationship between time and the amount of money that you have invested. It is obvious that the relationship is not linear, rather is a curve that you will learn later on. Now this relationship very gradually increases as time increases up to here, and then suddenly the amount increases as time increases. So at the beginning, the increase is not that much, but suddenly it starts increasing much more than the time increases. The next example shows the relationship between the temperature of coffee and the time. Again, as you can see, the relationship is not linear since it's a curve and it's not a line. At the beginning, the temperature decreases much rapidly as the time increases, and then the temperature decreases much slower. The next example is the relationship between the crop yield and the fertilizer used. Again, the relationship is not linear because it's a curve. As you can see in this region, as the fertilizer used increases, the crop yield increases too, and then gradually the crop yield decreases as the fertilizer used increases. In the next example, we have a graph between number of birth and the year in Ontario. You're supposed to describe the trends in this graph. Now, as you can see from the graph, one part of the graph is here where the number of birth increases. Then from this point to about this point, the number of birth is decreasing. Then from here to here, the number of birth is almost constant. From here to here, the birth increases, then decreases from these two extreme points, and then starts increasing gradually. So the way we can say, first of all, if you look at the x-axis, every box is 5 years. So you have 1945 to 1950, 55, 60. So from 1945 to 1960, the number of birth increases rather rapidly. Then from 1960 to about to 1965, 70 to 1975, the number of birth is decreasing from here to this point. It is gradually decreasing. Then from 1975 to 1980, the number of birth is almost constant. From this point to this point, it's almost constant. And then from 1980 to 1985, the number of birth is slowly increases, and then suddenly from 1985 to 1990, it increases. Then again, from 1990, which is this point, to 2000, the number of birth decreases, and then from 2000 again, it starts increasing. The next example, we are going to see how we can use the trends to make prediction and justify decisions. Now, the prediction that we are talking about here, if you remember, are interpolation and extrapolation. Again, to refresh your memory, interpolation is to predict a value for a data point which is between the range of value given on your graph. This is called interpolation. Extrapolation is when the point that you want to predict is going to be outside the range of data points given. In example 3, we have a graph, and we are supposed to predict the number of Canadians in age group at 2010. So we have to predict at 2010, which is somewhere to the right of the graph, somewhere around here, which is not given, how many age 15 and under we have, and how many age 60 and over we have. So in this area, we have to make our prediction. To do this one, what you have to do is you have to extend the trend, and you have to extend your graph. So we know that this graph is going to go like this, so we are going to continue the trend to the right, and also this one, we are going to continue the trend to the right. Assuming, of course, that the trend continues to be the same way. If we do this one, then what we are going to get, we are going to get a graph like this. Now, just remember that every box here is 2 years. So 1990, 92, 94, 96, 98, 2000, 2002, 4, 6, 8, 10. So 2010 is going to be right here. If we look at the trend, we will see that this point and this point is the one that we are looking for. So we can say at age 80 and over, the number of population is about 1 million. And at 2010, the number of people age 15 and under, or age 60 and under, is around 6 million, 5.8 something. Now, just remember, our assumption is that the trend continues the way it's doing before 2010, meaning the trend is going downward for age 15 and under, and it's going upward for age 60 and over, and our assumption is that it's going to continue the same way, and it's not going to have a sharp, change going up or down. Our next question is, based on this trend at 2010, What decisions might the Canadian government make in response to the trends in the graph? As you can see that the number of population of age 15 and under is decreasing, but age 60 and over is increasing. So probably what the Canadian government can do is it can bring more immigrants from other countries to stop the problem of having future labor, the shortages. It can increase the retirement age, so this age 60 and over can still continue, supporting the job market. And since the older age group is increasing, the government can uh, make healthcare a little bit stronger, social security to be better, and also address the needs of older people.